then you got a CH2 here. CH1. You can fix this green in a little bit to go on that one. So what do we got? Got a double bond here. Double bond there. Got the sulfur we still got to do in green here. So see, it can get a little tricky up there the way we had to get the sulfur so that the points were next to each other, because those are two of the different diamonds the way we draw it. So this is a tough molecule to draw the Lewis structure for, but look how easily we did it. Okay, these greens filled in all the way. Black them, green them out. Methyl's on the end there. Where's our purple? So H2's get the lavender reddish one. Pinkish red this time. We got a 2 here. Where's the Schroeder Diamonds? Got one right here. And here. And one gets brown, right? And there you go. MalaTHION. It's famous for being a colon esterase binder, and once it binds, it don't let go, so it renders that enzyme useless. So anything with the, I believe the what, acetylcholinase, acetylcholine. So there you go. You want to draw some aliens in there, you can. Got aliens up here if you wanted. If you're into it. Again, this is one that'll really show, you know, all these electron pairs. How do you think this thing acts in water? You got a methyls on these sides, not like in water, but then you got these sulfur electron pairs, oxygen electron pairs. So I'll bet water puts a big strain on this and breaks it in half, huh? It's an insecticide, so it's being taken up by the insects. And I guess we have something to where it doesn't bind to our cholinesterase, but it does to an insect. Okay. So moving on. There's one called Jasmonic Acid. You see that up there? This is plant hormone. Slows to growth and kind of tells it it's time to go. You've been around too long. So let's start with 5-membered ring here. One, two, three, four. Oh, it goes to a diamond even. Let's see, but it's going to need the double bond up there, so we got to draw the diamond kind of like that. What it's going to do is go one there, one there. Okay, double bonded over there. So that's a ketone outside of the ring. That's not a like the ribose rings we're used to. It's a ketone right out there. Now this, they kind of draw backwards. So we'll draw it like they do too. It's just still a diamond again, no biggie. Diamond to a diamond to a double bond going that way. So there's double bond. And that's going to go to 2 more carbons off there. 1, 2. What do we see? That's a methyl on the end, so we can get that done. 3, draw the double bond like I always say. That was this one, right? Yellow shows up really good on the camera, not so much in person. Let's see, I guess we'll keep coming around. This is just a CH2. Double bond only allows for a 1 and a 1. This is a CH2. We've got a carboxylic acid coming off the bottom here with another one. So that's actually an F. F is 2. And the double bond, there's our green marker here. It's double bond O. And the old proverbial OH to make that a carboxylic acid. Straight hydrocarbons here. So this can get 1. We got a 1, 2 here. Got a 1. These are going to get 2s. So we could have done these different and put them 1 in, 1 out, which is a better way, but this is a great way for counting them anyway. So what do we got? Any Schroeder diamonds? I see 1 there. 1 here. Now the oxygen, as soon as you draw oxygen, they're done technically, so I haven't been coloring them in. But I should have had the yellow on that anyway, right? Oh, I have a restored faith in yellow. And we need a proton in here. That makes it the acid. Remember, without the proton, this thing will be ionized, and both those oxygens will be the same. But the way it is now, one is a proton, one's double bound. So that's that part. What do we got? Brown is the 1s, I believe, isn't it? I may have backed that up before. So any with 1 get brown. There's 1s because of the double bonds. 2s, we're getting the scarlet red, which is going to be a lot. I got to find, there's the scarlet. I'm doing them pink, that don't count. So if you had to go through and count the carbon, hydrogen, oxygens, count on these things, that'd be nothing, would it? Because they're all different colors and stuff. So there's Jasmonic acid. It's a plant hormone. I color like I'm 5 years old, don't I? Look at them. I can't even stay in the lines. Here's a 2. 2s get the scarlet. So see, just picking the different color makes you think about it. You don't just jump in. They're carbons, they're carbons, they're carbons. Okay, there you go on that. Pretty cool. I think so, for whatever my cheap opinion's worth.